In my last video on prefixes and dimension analysis, I cut the video because it was running for too long. If you didn't check out that video yet, be sure to check it out in the description boxes below. And in this video, we're going to talk about significant digits. So significant digits is essentially used to communicate the accuracy of the measured values. So take this line for example. Let's say you want to measure the length of this ruler. The best you can tell is that it's somewhere between 11 to 12 centimeters. So in other words, you're not confident as of the decimal point. You're not sure if it's 11.5 or 11.6 or 11.7. So when you report the length of the line at 11.6, there will be two significant digits because the two digits 11 you are sure of, and any other digits you're not sure of anymore, and you're just sort of extrapolating it based on your eyeball. And obviously, if I get a more accurate ruler, I can be sure of more digits, and I will have more significant digits and therefore more confident in the accuracy of my value. So a good way of thinking about significant digits is the number of digits that you are sure of. A few rules on determining how many significant digits are in a value. Non-zero digits are always significant, and zeros between non-zero digits are also always significant, and definitions and counted values have infinite number of significant digits. Because if you think about it, 1 kilometers is equal to 1,000 meters. That's a value that we define, so you can't really be unsure about accuracy of that definition. And same with counted value. If you have 3 books, you know for a fact that there are 3 books, you know exactly that there are 3 books. So they have infinite number of significant digits. And significant digits, the hardest to determine is always 0. And a rule of thumb is filler zeros are insignificant. And you might be wondering, what are filler zeros? So take this number for example, 0.000000025. See, the 6 zeros in front, the only purpose they serve are placeholders. And the only reason they're here is because this is a really small value. And in order to tell people that it's small, we put a bunch of zeros in front. So these zeros, they're just there because the value is small. So here is a rule that I think it's quite effective in determining whether or not the 0 is significant. So if a number has a decimal and the number is greater than 1, all the zeros are significant. So in this case, 200.00 or 30 point, this has 5 significant digits and this has 2 significant digits. And if the number is less than 1, all the zeros to the left of the first non-zero digit is insignificant, and all the zeros to the right of the first non-zero digit is significant. So for example, there's 4 significant digits over here because these 2 zeros are to the right of the non-zero digits. So if you think about it, these zeros are only here because the number is small and we need to put it there as a placeholder. But these zeros are here because they are sure that the values over here are 0. They're sure that it's not any other digit. They put this 0 here because they're confident in that value, making this number having 4 significant digits. And if number doesn't have a decimal, all the zeros are insignificant. Again, these zeros are only here as a placeholder because 2,000 is a big number and you need 3 zeros to tell people that it's 2,000. Significant digits with scientific notations, it's really easy. All the numbers in front of the exponents are significant. So this has 4 significant digits and this has 1 significant digits. And significant digits with pH. pH is, if you learn chemistry, it's essentially the measurement of the acidity of a solution. If you keep in mind what I say, significant digits are essentially a measurement of how accurate the numbers are. So in this case, 7.025 has 3 significant digits, and 12.02 has 2 significant digits. And the reason you count after the decimal is because the pH ranges from 1 to 14. It wouldn't make sense that, for example, a pH of 12 have more significant digits than a pH of 7. The only reason that the pH is 12 is that it's basic, so it wouldn't make sense to count before the decimal point, because before the decimal point, it's essentially just how it ranks on a scale, whether it's basic or acidic, and it's what's after the decimal point that's important because that shows how accurate the measurements are. So significant digits and rounding. Final answers should be rounded to the same number of significant digits as the number has the least number of significant digits. So I know what I just said, it doesn't really make much sense when I say it theoretically, so let's do a practice question. So if Bob read 2 books in 6.0 hours and each book weighs 1 kilogram, how many books did he read per hour? It's a simple division question, there are no tricks involved. 2 over 6 is 0.3333 and there are infinitely many 3s. But what I'm trying to get at is how many significant digits should you leave. So remember, this is a counted value, so there are infinite number of significant digits. This is a measured value because you measure time. There's 2 significant digits. There's 1 significant digit because weight is also a measured value. But the thing about weight is it's never used in this question, so you can sort of ignore it. And you have to consider what's the least number of significant digits between these 2 numbers. Infinite and there's 2. Obviously 2 is less than infinite, so you keep 2 significant digits at 0.33 books per hour. So that's the end of this video. I think for the next video, I'll sort of put some practice questions up for prefixes, dimension analysis, and significant digits so we can get more practice. That's it for the video. Thanks for watching. Be sure to like, comment, and subscribe.